This is problem 20, problem set 29, number 28. The area of this figure, this house-shaped thing, 8, 12 miles, and they tell us that this is also 12. Okay, so what kind of a shape is this here that we have? What kind of a figure is it? It's a pentagon. Is it a regular pentagon? No, because the sides aren't all the same length. Okay, do we have a formula for the area of an irregular pentagon? No. So how are we going to have to find the area?
Area of the triangle. Bottom of that one.
And the area of the, well, what's the other shape going to be?
Rectangle.
Right, so we got a triangle and a rectangle. Okay. The area of the triangle, how do we find that? Yeah, base times height over 2. Or I actually prefer 1/2 base height. It doesn't matter which one you use, they're the same. So what's the base of this triangle?
12.
Is 12, and what's the height?
4.
How'd you get 4 for the height?
Because the maximum height is 12 and the rectangle has 8.
Right. This is 8 miles high, the whole thing's 12, so that's gotta be, this has gotta be 4. Right, so 1/2 times 12 times 4 gives us what?
12 times 48.
Times 1/2.
24.
24 square miles. And then the rectangle, 8 by 12, 96 square miles. So the total is 24 plus 96, or 120 square miles. Any others from 29 you want to go over?
20.
Number 27. Okay, so this figure here, this is, we got, let's see, 21, 29, 46, 11, and 19 feet. Okay, to find the perimeter, we're going to have to add up the length of all the sides, right? Yep. Okay. Okay, the problem is this trick where you use these measurements twice doesn't work if it's a U shape. It only works if it's an L or a stairs kind of shape. If it's a, and we'll see why. Right, because, so here, okay, here we've got 46. And on top we also have 46, right? Because these three, which they didn't tell us the measurement of, we don't know exactly what the length of each one of them is, but we know they add up to 46, right? Because we've got 3 rectangles next to each other. So the lengths, the widths are the same. Okay, so that will work. But this one here, 29, we are going to have to add in 29. But if we add in 29 again, we're not going to get the right answer. Why? Because over here, we have these 3 vertical pieces, which actually add up to significantly more than 29. Notice 21 plus 11 is already more than 29, it's 32. And then we add another 19. So we want to add each of these sides. So we've already gotten this bottom, these top bits, okay, 29, that's over here. Now we still need to add in these 3 sides, 21, 11, and 19. And then we can add up 46 and 46 will give us 92, 29, 21 give us 50, 11 and 19 give us 30. Okay, 92 plus 80 is 172. The trick, this trick where this is 46 and that's 46, you got to be careful when you've got a U shape because you won't always be able to use that. Here, it works for the top and the bottom, but not for the side. Because these vertical sides here do not total 29. Next. Any others from 29?
Wait, what was the answer to 26?
26 was -7/3, yes. Going once, less than 29. Going twice. Okay, moving on to problem set 30. Problem set 30, so take that out. We'll read off the answers, and then we can go over it. Everybody got it out? Yes? Maybe? Please? Please? Number 1, positive number. 2, trapezoid. 5, 12 centimeters. 6, 5n minus 8. Or if you use a different variable, that's fine. You could say 5x minus 8 or whatever.
Yeah, 5 inches, 5 times 10, right?
Yep.
I can afford.
I got 42, because I timed 5 and 3. I'm supposed to do that.
No, we'll take
supposed to solve, right?
we'll take a look at that in just a second. We'll come back and we'll go over those two for sure. These two, 6 and 7. 7 is 3 parentheses -n minus 7 close parentheses. 8 is 26. 9 is 0.75. -1. 13 is 28. 14 is 98. 15 is -11. 16 is 10. 17 is 49/3. 18 is 13/2. 19 is 17/5. 20 is 100. 21 is 5. 22 is a to the -2, x to the -4, y to the 8. 23 is p squared.
It's called P2.
P squared.
P2.
Isn't it?
Solve.
What?
Nothing.
Okay. 24 is 3m squared x squared y plus 8m squared x y squared. 25 is 1 minus 3xy squared. 26 is 36. 27 is -37. 28 is 60 plus 12 pi meters. 29 is 150 square kilometers. And 30 is 160 pi cubic inches. Any answers you want repeated from 30? All right, turn to page 127 in the textbook, problem set 30, so you can have that in front of you. Any problems you want to go over from problem set 30? Let's actually talk about 6 and 7 first. So 6, we've got the sum of 5 times the number and -8. The sum of 5 times the number and -8. So what's the first word there? The what? What are we talking about in number 6 here? The sum. Sum means what? Addition. What things are we adding together? The sum of what? Of what two things?
We're adding.
5 and then 3.
No, I got it. We're not supposed to solve.
You can't solve. Solving is not possible for these because they're not equations. What are the two things that we're summing together? The first one is no.
-8.
No. Somebody read number 6 aloud for me.
The sum of 5 times the number and negative.
And what? And what?
-8.
Yes. Okay, so what's the first thing that we're adding?
You're adding the sum of 5 times the number.
We're adding, right, the sum of, the first thing is 5 times the number. Or 5n, or 5x, or whatever you want to use. The sum of that and what else? -8. Anytime we have the sum of, or the difference of, or the product of, there's always going to be at least 2 things involved, because otherwise you can't do an operation with just one term. So the sum of the first thing and the second thing. And here the first thing, the sum of, the first thing is 5 times the number and -8. Yes? Everyone see how I got that? So 5n plus -8, or you could have written 5n minus 8. If you want to use a different variable, great, knock yourself out. There's nothing else that we can do from here. We can't solve, well, first of all, we can't simplify this at all. And we can't solve it because there's no, it's not an equation. All we have is 5n minus 8.
Would still be ready to put parentheses 5 times n, parentheses minus 8.
Say it again.
You put parentheses, then 5 times n, and then like parentheses then.
Like that?
Yeah.
Yeah, that's fine. You don't need the parentheses because our order of operations already tells us to do multiplication before subtraction. But if you wrote it like that, that's fine. All right, now 7. 3 times the sum of the opposite of a number and -7. So, the first thing they tell us is what? 3 times. Okay, 3 times what? So 3 times something. What's the thing that we're multiplying by 3? Ah, the sum. So we're multiplying 3 by some sum. You see why I have to write it like this? Because the thing that's getting multiplied by 3 is the sum, is the total. Before I can multiply whatever the sum is by 3, I have to figure out what it is. So I have to do the addition first before I can multiply. Otherwise, I'm not multiplying the sum by 3. I have to get the sum first and then multiply by 3. And what is it the sum of?
The opposite number.
The first thing is the opposite of a number, which we write as what? Negative what? Negative n. And what's the other thing in the sum? Right. So this is the sum of the opposite of a number and -7. Right? Negative n means the opposite of a number. The sum of the opposite of a number and -7 is this. And we want 3 times that. Yes?
I have a question. So if you were then to go and put negative x plus negative, minus, minus.
Say it again?
So if you distribute.
You can distribute, and then you can. What would you get if you distribute?
Negative 3n, and then minus 21.
Yeah, negative 3 and minus 21. That's fine. You could write that also.
Because I have both of them.
Yeah, that's fine. This is exactly what they said, but this is an easier thing to work with probably, depending on our problem. We can always move between these. We can distribute, we can factor out, that's fine. Okay, other ones from 30 that you want to go over. Make sure that you understand how to do problems like that. If you're confused, try the practice problems on page 126. I'm sorry?
Like, when I was in public school, we learned how to, we took, something like that, and then we were able to, undo it. I forgot what it was called.
To undo distribution? Yeah, it's called factoring. We're going to do it later in the year. Yep. The way that it works is that we look at this and we say, well, I can divide both of these. I've got 3n. Really, I've got 2 things being added here. I've got negative 3n. I've got negative 21. And we see what can I divide both of those by. We find out we can divide them both by negative 3. Right? We can divide this by negative 3 and this by negative 3. So we get negative 3 times n plus 7.
We try one.
Like this?
Yeah, like the fact.
Not right now. We'll wait till we get there later in the year. All right, other questions from 30 that you want to go over? You guys are feeling comfortable with these? What about number 16? Did you guys get 16 and 15 and 16 right? Right. 15 was 15 is negative 11 and 16 is 10.
Yeah.
You understand functional notation? All right. What about number 25? How do you feel about number 25?
I got it.
Like, I got it wrong, but I know what I did. I just didn't put the minus one. I just didn't put the one in the front.
Oh yeah.
Oh,
Yeah, so let's actually do that one because there are a couple of good things to talk about here. So this is 25 from problem set 30. They want us to use the distributed property on this. X to the negative 4, y to the 0, times x to the 4th minus 3, y squared, x to the 5th, p to the 0. Now, anytime we have a problem where we're doing something to it, in this case distributing, before we actually start doing a distribution, let's see if we can make our lives easier. What are some things we can do to this to make our lives easier?
P to 0 and y to 0 is 1.
Right, so instead of writing y to 0, we can write 1. What's x to the negative 4 times 1?
1 x.
Yeah, we don't need to write anything there. We can just write x to the negative 4. If we don't write a coefficient, it means 1 times. Okay, then we got x to the 4th minus, and so what is this going to become? What is this term going to become? Instead of 3y squared or negative 3y squared x to the 5th p to the 0, what will we have?
-2. Or negative 3y squared x to the 5th, 1.
Right, times 1. Instead of multiplying by p to the 0, p to the 0 is 1, so we multiply it by 1. So it stays the same. Right? Yes? Notice with both of these, when you have a term that has something to the 0th power as one of its factors, you can just drop that because anything to the 0 power is 1, and multiplying by 1 doesn't change the rest of it. We could take this and multiply by 1 all day long and it's not going to change. Okay, so now we've made our lives a little easier for when we distribute. So when we distribute, remember we take the term, the coefficient that's outside of our parentheses, and we multiply every term inside the parentheses by that. So first we multiply this way. What's x to the negative 4 times x to the 4th? How'd you get x to the 0?
-4 plus 4 is
Right. Remember when we multiply things that have the same base, we add the exponents together. Negative 4 plus 4 gives us 0.
Wait, so that would that mean it'll turn into 1?
Yes.
Oh, that's cool.
It turns into 1 because it's x to the 0, or more simply written 1.
Oh, that's
And what happens to the second term? What happens when we multiply negative 3y squared x to the 5th when we multiply that by x to the negative 4?
Minus 3y squared x to x.
Minus 3y squared x. Because what we're doing is negative 3y squared x to the 5th times x to the negative 4. This is all multiplication. Negative 3 times y squared times x to the 5th times x to the negative 4. And these two, when we multiply them together, we add the exponents. 5 plus negative 4 gives us 1. X to the 1, or just x. That's how we got our answer here. Couple things to keep in mind. 1, make your life easier. If there are things you can do to change something into a more convenient format, do it. That's what algebra is all about. Making things more convenient for yourself by manipulating terms and equations. Then also, remember your rule about adding exponents, and that anything to the 0 power is just 1. Questions about 25? Or about any of the other problems from problem set 30? Okay, turn to page 128, lesson 31, equations with parentheses. Seeing if Blake working on that paper?
Absolutely.
Yeah, good. All right. Equations with parentheses. So we're continuing to expand our ability to solve algebraic equations. We started with ones that just had some multiplication or addition involved. Then we had some that had them combined. Right, so if you have like something like 5x plus 2 equals 12, like that, where it's got multiplication and addition going on. What's our general rule, do you remember, for when we're solving equations? What are we trying to do when we solve an equation?
Yes.
Yeah, what's the goal? What does that mean to solve an equation? Okay.
Take the least steps.
But what does that mean to solve an equation? An algebraic equation, to solve it. This is a definition we talked about a few lessons ago. What was that? Getting a solution. What's a solution? What does that mean, a solution to an algebraic equation? Okay, yeah. Anyone? Maybe it's in your notes. Let's see.
That's a hard
We could talk about this in lesson, let's see. Uh, 22, lesson 22. Look at lesson 22. What does it mean when we're solving an equation? You can find this on page 96 in your book.
You should, he's 96.
Yep.
Find what X is.
Can you be a little bit more precise?
A replacement of values for the variable that turns the equation into a true equation are called solutions.
Yes, solutions. The solution of an equation is a value that we can plug in for the variable that will make that equation true, that'll make it balanced. So for example, if we have, 2x equals 6, the only value of x that will make this true is if x equals 3. Remember, a variable is a mystery number. It can represent anything. If x equals anything other than 3, then this will be false, because 2 times 4 is not equal to 6. You write 2 times 4 equals 6, that's just not accurate. That's false. So we're looking for values that will make this work, that'll make it true, that'll make it balanced. When we're trying to find solutions, we're always trying to do what with the variable to get a solution?
Get it by itself.
Get it by itself. How are we going to get it by itself? By doing various operations to it. How will we know which operations to do to our variable? So in this example, in this one, for example, 2x equals 6. What am I going to have to do to x? Divide by 2, right? Because right now, what's happening to x? It's being multiplied by 2, so I need to undo that. Whatever is happening to our variable in the equation, we need to undo it to get the variable all by itself. All by itself. How do I know, if I have multiple different things going on, how am I going to know which one to do first? So if I have something like this, if I have 3x minus 2 equals 10, how am I going to know there's two things happening to the x there? There's multiplication. Why?
Looking at the other side.
But how am I going to know which one of those two to undo first? Between the...
So on the right side of the equal sign, and there's none with the x.
Well, we do always want to get to the point where the variable's on one side, but how do I know which one to undo first? Yes, we use reverse PEMDAS. Or SADMET. SADMET. Doing these things. What happened here was first x got multiplied by 3, then we subtracted 2. So if we're undoing that, we need to go in the reverse order. First, we're going to undo the subtracting 2 by adding 2. Then, right, so we'll add 2 to each side, we'll get 3x equals 12. Then we'll undo the multiplication by dividing by 3. We go reverse order of operations. Yes?
Yes.
Okay, so what if we have an equation like this? 2 parentheses 3 minus b equals b minus 5. Start you off with a slightly tricky one.
You have to what is it called?
Multiply by 3.
Like do the,
6 minus 2.
what is, I forgot what it's called.
What do we always want to do here? What do we?
Do the parentheses first, like do the two.
Yeah. The problem is the parentheses are going to mess with things because it makes it a lot harder for us to do our reverse PEMDAS because the parentheses should be the last thing that we deal with. But if we try to do those parentheses last, like the variables inside the parentheses, funky things are going to happen. So anytime we have parentheses, we want to try to get rid of them because getting rid of the parentheses will make it easier for us to do our reverse PEMDAS.
Is that a B?
Yes, it's a B. How can I get rid of these parentheses here? Any guesses? Yes?
2 times 3. And then 2 times negative.
Yeah, so what do we call doing that?
I don't know what, it starts with a D, yeah, distributing.
Yeah, distributing, right. We can distribute out this 2, and that'll let us get rid of the parentheses on the left here. So we do 2 times 3, we get,
6.
we do 2 times negative B, we get,
Negative 2.
okay, and then B minus 5. Okay, now this is much better because now we don't have any parentheses. So we're adding a new step onto the beginning of how we solve these equations. First thing is always going to be getting rid of parentheses. Once we get to this point, what do we then want to do?
Negative plus, probably since we don't do plus 5, and then
So we'll add 5 where?
to the other side,
Just there?
like to the other side,
What do you mean the other side?
to 6.
Like this?
Like the way you did it originally, yeah, we did on this side.
Ah, on both sides, right. Okay, we'll add the same thing to both sides. And then we'll have 11 over here minus 2b equals b, right? And what else do we need to do still?
Add 2b on both sides.
Add 2b to both sides. Then what do we get? Then what do we do?
Divided by 3.
Parentheses. That's a new first step. Eliminate parentheses. To one side, we'll move the constants. Then we'll do reverse PEMDAS. Solve. Oh wait, I skipped a step. Sorry.
Oh, those hurt. Those hurt. When you write a lot, you just have to break them in first.
He said like, I ordered it, he was like, you read them?
We're also going to combine like terms if there are like terms. Let's do the next one. 31.2. 3 times 1 plus 2x, parentheses, plus 7 equals negative 4 x plus 2. Yeah, I'm actually going to change this. I should read this in the other. This should be step 2.
Distribute.
Distribute. What happens when we distribute over here?
Yeah, 3 plus 6 plus 7 equals negative 4x minus 8.
Yes. Okay. Then let's add like terms.
3 and 7 will give you 10 plus 6x equals negative 4x minus 8.
All right. Now what do we do?
Add negative on both sides.
You could minus 10 on.
Okay. So remember, we need to move the variables to one side and the constants to the left.
Add 4 on both sides.
Add 4x to both sides. All right. That'll undo that. All right. We'll have 10x over here. How do we need to move the constants to the other side? How do we get the constants to the right?
Minus 10 on.
Subtract 10 on both sides. So we get 10x equals negative 18. Then what do I do?
10
Divide by 10. X equals
9, 5. 9 was
Negatives.
Negative 9 over 5. Yep. Negative 9 over 5.
Do you have to like, make it a smaller fraction?
Yes, you should always simplify fractions if possible. Yep. Let's do one more. Actually, do you guys want to do another one, or do you just want to start the problem set?
That's
Okay, all right.
Or, the pen thing didn't get off. I'm not getting trouble.
It didn't come off.
When I get home, I'm gonna wash it off. I'm
Bro,
gonna
it
try.
didn't,
I'm gonna get a sponge.
It's changing.
My mom,
Okay, problem set 31. Same deal, all except 3 and 4.
Why?
no,
Right.
and that.
So there you go.
Bye.
Just see you walk on.
But yeah.